In the previous lessons, we learned how to balance chemical equation. And to balance chemical equation, we change the coefficient so that the reactant is equal to the product size. Now, if we look at this, if this is an equal sign, that means they are equivalent to each other. Well, if they are equivalent, because they are equivalent or equal to each other, we can now express them as a relationship in terms of conversion factors. So this equal sign right here, when we have a balanced chemical equation, we now have conversion factor from a chemical equation. And the unit of measurement that we are going to use is going to be in mole. So let's use mole to represent our conversion factor. Well, we have 1 mole of nitrogen is equal to 3 moles of hydrogen is equal to 2 moles of ammonia, NH3. You see how that works? So that's the power of having a balanced chemical equation. So let's solve a problem together. How many moles of hydrogen are needed to produce 25 moles of ammonia? Well, in this case, if we look at this problem, this is our given. And no longer we've only focused on mole, but now we have to focus on the chemical as well. So we're going from mole to mole with different substances. If we look at this, the only 2 chemicals that we care is NH3 and H2. So those are the 2 chemicals that we care most. Now, if we express this as a conversion factor, that's pretty easy. See that number in front of the chemical? That is your coefficient. So basically 2 moles of ammonia equal to 3 moles of hydrogen. And there you go, we have our conversion factors. And going back to solve the problem, we always use the same strategy. Take our given times the conversion factor, as many as needed. Well, our given is 25.00 moles of ammonia. Time the first conversion factor. Well, look at this conversion factor. It has mole and mole, specifically moles of NH3, which is right here. So we want to cancel out moles of NH3, so that's going to be on the bottom. So the same strategy, okay? If moles of NH3 is on the bottom, this moles of hydrogen will be on top. And notice how mole of NH3 cancel out. Now you're not only looking at the unit, but now we're going to focus on the chemical as well. So that's the biggest challenge when we come to solve from mole to mole. Now let's plug this into our calculator. Again, multiply everything on top divided by every number on the bottom. So we have 25 times 3 divided by 2. This gives us 37.5. And we want to keep 2 decimal places. So what we have here is 37.50. And what's the unit going to be? Well, the only unit that did not cancel out is moles of hydrogen. And this is the work that I would like you to show on your paper. Let's try another problem. Here we have a balanced chemical equation. And how do we know? Again, the coefficient there. Or you can just double check. If it is balanced, you can think of this as an equal sign. Or you can think of the plus sign as an equal sign. So that tells you we have 2 moles of, in this case, C8H18. That is your octane. Well, octane is the main chemicals in your gasoline. Well, 2 moles of octane is equal to 25 moles of oxygen. And that is equal to 16 moles of carbon dioxide. And that is equal to 18 moles of water. So they are equivalent or equal to each other. So you can choose any chemical of your choice and make it a conversion factor out of it. Well, octane is the main chemical in gasoline. The reaction produces how many moles of water from 55 moles of oxygen. So our 2 chemicals that we are going to work on is from our given right here, which is oxygen. So we are going to focus on that one. And the other one is produce how many moles of water. So based on the problem, we determine which two chemicals that we're going to work on. Well, in this case, if we were to look at this, the ratio between water and oxygen is this. Well, that right there, 25. So give us 25 moles of oxygen equal to 18 moles of water. And this is our conversion factor. So let's solve this problem. Again, we use the same strategy. Using our given time the conversion factor as many as we need it. In this case, we only need one because we start with mole and we end up with mole already. So again, we start with our given, which in this case is 55 moles of oxygen, time our conversion factor. And if we look at this conversion factor, this is mole of oxygen, so on the bottom must be mole of oxygen as well. So we have 25 moles of oxygen. And what's on top? The remainder part, which is 18 moles of H2O. And that cancels out. Now notice how moles of oxygen cancel out. And all we have to do now is plug this into a calculator. And notice how we just multiply by one conversion factor and we get exactly what we're looking for. Okay? Because just mole to mole. So plug this in our calculator. Again, multiply everything on top and divide by everything on the bottom. 55 times 18 and divide by all numbers on the bottom, which in this case only 25. And we have 39.60 because we want to keep two decimal places. So we have 39.60. And what's the unit going to be? Moles of H2O. There you go. And this is the work that I would like you to show on your paper.